Hello, hi everyone. Welcome to this Two in the Brand. Is it audible? Hello, hi everyone. Welcome to this Two in the Brand. Yes. No, it is. Yes. So today topic is system of particles and system of particles and rotational motion. Hello students. Welcome to this Two in the Brand. Today topic is system of particles and rotational motion, system of particles, and rotational motion, rotational motion. Okay, suppose if I'm considering the book, this is a book. If I take the book like this, okay, so consider this book mass is m. Okay, so if you hold at particular point, so to this book, so we can able to balance the entire mass. So generally we will hold like this, right? So we will hold like this. Understood or not? So if you hold here, we can able to balance the book easily. Generally, so normally we'll hold the books like this. So if you're holding like this, it feels like little heavy. And if you hold like this also, exactly if you hold here, so we can able to carry this book over a long distance. Okay, so so the total mass of the body will be concentrated at particular point. So even if you hold here also at the center, if you hold at the center also, we can able to balance the total mass. Okay, so that is the center of mass of the body. The total mass of the body will be concentrated at one point. So that is called center of mass. I hope it is very clear. Okay, so the total mass of the concentrated particular point, the total mass of the body will be concentrated at one point, that is called center of mass. Okay, so that is the point number one. And coming to the point number two, okay, so here I took only one particle or one book, one object. If I take two objects, so two particles, so here this the particle, I'm taking the object mass m1. So suppose I'm taking the particle, so here particle m2, the center of mass will be at the center. Anyway, we know that. So the center of mass of the two particles will be consist at one point, so at one center. Okay, so from m1, the center of mass is r1, the distance or position of center of mass from m1 is r1. So now here position of center of mass from m2 is r2. Position of center of mass from m2 is r2. Okay, so the total distance from m1 to m2 is d. Okay, that is the distance. Total distance. Understood or not? So once again, observe carefully here. So I'm taking two particles. So initially, if you take one body or one particle, so we know that the center of mass will be lies in that particle on. Okay, at one point. The total mass of the body will be concentrated at one point. So if you hold that point, we can able to balance the entire body, entire object. Here two particles are there. So if two particles are there here, m1 and m2. So two particles masses m1 m2 are, So separated by a distance d. Okay, center of mass lies at the center. Anyway, we know that center of mass lies at the center of the two particles. From M1, the center of mass position is R1. From M2, the center of position is R2. Okay, that is the position. Position of center of mass from M1 is at a distance of R1. So position of center of mass from M2 is at a distance of R2. Okay, so the distance between M1 and M2. So the particles are separated by distance is D. Okay, so now if you are taking, so R1 position, R1 equal to, that is nothing but M1 R1 equal to M2 R2. Okay, so both are balanced. Both are balanced now. So center of mass lies at the center. If two particles are same mass, if different masses, so M1 if you are taking M1 R1, so R1 equal to M2 D by M1 plus M2. So suppose R2 position, R2 if you want to find out, M1 D by M1 plus M2. M1 plus M2. So this is about only two particles system. Okay. Suppose you are taking only two particles. If I take n number of particles, if I want to identify this center of mass, how we have to consider? We will check here. Okay. So if n number of particles are there in a system, okay, so I am taking only two particles as a system. If n number of particles are there, okay, suppose this is M1 and here is the center of mass. So from here to here is R1 and here is M2. So likewise here R2 and suppose M3 and from this one R3 and suppose and so on and so on. So I am taking this the Mn and the distance is and the position of center of mass from the particle is Rn. Okay, if n number of particles consider, then the center of mass, okay, position of center of mass, RCM equal to M1 R1 plus M2 R2 plus and so on Mn Rn by M1 plus M2 plus M3 and so on Mn. Okay, na? So likewise you have to consider. Understood or not? RCM, position of center mass. This is a position of center mass. So if vector position, vector if you are taking, so RCM bar if you are taking position vector M1 R1 plus M2 R2 bar and so on plus Mn Rn bar. Okay, vector notation. So M1 plus M2 and so on Mn. Okay, so now this is about the position vectors. Okay, so center mass of the position vector of the system, n number of particles, Okay, so now if you are taking, if you are considering RCM equal to, we can write sigma I equal to 1 to n mi ri by sigma I equal to, so 1 to n, that is m. Okay, so from 1 to n equal to, so mi ri equal to n1 sigma 1 to n, that is equal to m. Understood or not? This is the total mass, summation of masses. Okay, summation of mass and summation of total we can consider like this. Understood or not? Now if you are taking velocities in the form of velocity, so velocity if you are taking VCM bar if you are taking, okay, so that is M1 V1 bar plus M2 if you are taking two particles if you consider by M1 plus M2. So if you are taking acceleration, so ACM equal to center of mass of the acceleration Okay, so that is, so m1 a1 bar plus m2 a2 bar by m1 plus m2. Understood or not? So if you are taking momentum, momentum is nothing but, so P equal to mass into velocity. Okay, momentum of center of mass, so VCM bar. Understood or not? So like this we can write, like this we can write. Okay, so I hope it is very clear. So I hope it is very clear. Understood or not? So this is system of particles and rotational motion. Rotational motion. I hope it is very clear. So likewise we have to write. Likewise you have to write. Understood or not? So next one. Next one. So we'll discuss about rotational motion or kinematic equations. Kinematic equations. So we'll discuss kinematic equations in rotational motion. So this is about is position, center of mass, position of center of mass, velocity of center of mass, and acceleration of center of mass. Position of center of mass, velocity of position vector, and velocity vector and acceleration vector of center of mass we discussed. Now along x-axis if you take, along y-axis if you take, along z-axis if you take, how it will be? So we'll see. Along x-axis, so along x-axis center of mass, along y-axis center of mass, along z-axis, if you are considering xcm equal to m1 x1 plus m2 x2. So if you are taking many, okay, so many particles along the x-axis, so by m1 plus m2, simply we can take ycm along y-axis center of mass, along y-axis m1 y1 plus m2 y2 by m1 plus m2 along coordinate axis, along coordinate axis. And coming to zcm along z-axis m1 z1 plus m2 z2 by m1 plus m2, m1 plus m2. So this is about coordinate axis, center of mass along x-axis, along y-axis and along z-axis. Understood or not? Center of mass along x-axis, along y-axis and along z-axis. I hope it is very clear. Understood or not? So now we will discuss about, so now we will discuss rotational motion. Rotational motion, sorry, kinematic equations in rotational motion. So here the particles moves in a circular path. So here I am taking, we know linear quantities. What are the linear quantities? I'll compare linear quantity with rotational quantities, then you can understand. So linear quantities, so distance, so we are taking x, yes, first one, and coming to the velocity, initial velocity, coming to the final velocity, initial velocity and final velocity. So u and v, and coming to the fourth one, coming initial velocity u, final velocity v, and acceleration e, acceleration e. So when it comes to rotational motion, okay, so here you can observe, so this angular quantities theta, angular displacement, so that is I am taking theta, okay. So in the form of this kinematics, linear quantities, kinematics and rotational motion. Okay, so initial velocity is omega 1, final velocity omega 2, acceleration is alpha. So we know that equation of motion, those are, so V equal to U plus AT, first one. Coming to the second one, S equal to UT plus half AT square. And coming to third one, V square minus U square equal to 2AS. And coming to the fourth one, okay, so, okay, SN, that is okay, fine. So V equal to U plus AT, S equal to UT plus half AT square. So V square minus C square equal to 2AS. Okay, so those quantities we are writing in rotational equation, kinematic equation in rotational motion. So omega 2 equal to omega 1 plus alpha into T. So T is same only, T is same. And coming to the second one, okay, so displacement omega theta equal to omega T plus half into alpha T square. And coming to the third one, omega 2 square minus omega 1 square equal to 2 alpha theta. 2 alpha theta. I hope it is very clear. Check once. So kinematic equation in rotational motion. Okay, so we have to consider like that. So we have to compare the quantities. We have to compare the quantities. Understood or not? You have to compare the quantities. Okay. So S equal to UT plus half it square. Then we can take U omega 1 because initial velocity. Okay. So I hope it is very clear. Next one we will discuss about one more point. That is parallel axis theorem and perpendicular axis theorem. Parallel axis theorem and perpendicular axis theorem. Parallel axis theorem and perpendicular axis theorem. So this is the mass of the object. Parallel axis theorem. Okay. So this is the moment of inertia. This is the moment of inertia at the center of mass. Okay, the distance is R, perpendicular distance. So I equal to any arbitrary axis. I equal to ICM. So moment of inertia at the center of mass. So ICM equal to capital M R square. So mass of the body, this is the mass of the body and the perpendicular distance. Coming to the perpendicular axis theorem. So here I am taking here mass. So this is along x-axis and this is along y-axis and this is along z-axis. Okay, so if you take this is x-axis, suppose I am taking this is so y-axis and z-axis. So iz equal to ix plus iy, sum of the moment of inertia along x-axis and y-axis. Okay. So this is a perpendicular axis theorem. Perpendicular axis theorem. Okay. So I hope it is very clear. Understood or not? So system of particles and rotational motion. So we have to do few problems related to this one. Related to this. Clear? So thank you so much. We'll see you in the next class.